Good morning, everyone. So, I will be discussing today normalization. This is just an example or a follow up example for the normalization topic discussed before midterm. So, to start with, let me show you this presentation. So, when you say normalization, it refers to modeling database from the real world scenario. So when you say real world scenario, these are the actual transactions being conducted or being performed by each organization. So an example of actual or real world scenario is your certificate of registration that you have received upon enrollment. So based on your certificate of registration or COR, you will be able to derive a database design from it by identifying entities and how these entities are related to each other. So let's proceed with this sales report form example. Let us normalize this one to third normal form. So when you say normalization, this is the process of organizing data so that redundancies will be eliminated or minimized. But the goal of normalization is minimizing redundancies because redundancy is still needed in database in the form of controlled redundancy because there are instances that you need redundant data to enforce data integrity in database. Okay, so normalization, we have three steps: the first normal form, second normal form, and third normal form. However, you can go higher normal forms. So you can go beyond third normal form, such as Boys Code normal form or the BCNF. And you can also proceed to fourth normal form and fifth normal form. However, there is a disadvantage when you overly normalize your database into the highest normal form. That is, you will be having issues or problems during the implementation phase. So the moment that you overly normalize or you reach the highest level of normalization, then you need to denormalize. So when you say denormalization, you have to merge or you have to combine tables to go back to the previous lower normalization form. So that is why in standard in standard we are considering third normal form. So this third normal form minimizes already data redundancy and eliminates the anomalies that can be affecting database performance and database integrity. So what are these anomalies? You have insertion anomaly, deletion anomaly, and update anomaly. When you say insertion anomaly, you will be committing this the moment that you insert the same data more than once, exactly the same data more than once. That's insertion anomaly. When you say deletion anomaly, the moment that you delete data from the database, and in the future you will be using that deleted data. So where will you recover it? So there's no way for you to recover it the moment that you have deleted it from the database. That is why in database standard, deletion is not allowed, meaning there will be no deletion of data in the database. Okay, even if it's more than 50 years old in the data, then you just have to keep it in the database. No deletion should be done. And then the last anomaly is the update anomaly. This update anomaly occurs the moment that you have two different values of the same data. Example, I have updated the address of student one. However, the other user were the moment that that user tried to pull up the address of student 1, it gives him a different value from my updated address. Okay, so let's go first to normalization, to this example. Let's go back. So this is the sales report form. The content is you have here the report code, the date it was the date that the transaction has commenced or has been performed. Then you have your customer, particularly for the export destination code and export destination name. Then your product, the unit price, and the quantity sold per product. So this is still unnormalized. Why? Because we have here multi-valued attributes. When we say multi-valued attributes, you have multiple data in one row. So example, if you will try to look at report code 1101 and 1105, you have here two records or two data pertaining to 1101 and 1105. So this is why this form is considered to be unnormalized. So to normalize it to first normal form, the first thing that you need to do is to remove these multi-valued attributes. You have to make sure that each row contains only one record. So how will you do that? Simple. You have to make sure that each row contains one record by breaking down the two records in one by one. So you have here report code 1101. It pertains to product code 11. Product code 101. For report code 1101 also, there is another record of product code that is 102. So that is coming from the multi-valued row or the multi-valued attribute 1101 here. When you transform this to first normal form, you will just have to separate those two records. The same with 1105. Now, once you're done with the first normalization form, you can proceed now to second normal form. However, before you proceed to the second normal form, you have to identify first the dependencies or the functional dependencies. This functional dependencies identification will help you identify how entities are related to each other and what are the entities involved in this database. So example, let's have here the functional dependency for the sales report first normal form. So you have three types of functional dependencies. You have the full, partial, and transitive dependencies. So upon creating the full functional dependency, you have to identify first candidate keys or the key attributes. If you recall in your chapter 2, when you say key attributes, these are attributes that we'll use to identify other values in the table. So more than one key attribute, we call it as a composite attribute. Now, the presence of composite attributes can be depicted or is presented with the full dependency. Given the sales report, you have composite attributes report code and product code. Now, this report code and product code will determine the quantity being sold per transaction. So meaning, given your report code and product code, you will be able to derive or you will be able to know the quantity sold or the quantity sold of that particular product in a particular transaction. So if you will take out product code and report code, you will not be able to know how much quantity has been sold for a particular transaction. So this is why we call this full dependency. When you say partial dependency, from the word itself, partial, meaning that other attributes can be determined by at least one key attribute, one of the composite attribute. Remember that we have two composite attributes. We have report code and product code as shown in the full dependency. Now, for the partial dependency, notice that for the first partial dependency, only the key attribute report code will determine the date of the transaction, the export code, and the export name. While on the second partial dependency, notice that instead of having both report code and product code, you only have product code that will determine the product name and unit price. That is why you call this partial dependency. Now, when you say transitive dependency, this is pertaining to a key attribute or a non-key attribute that will determine another non-key attribute. So in this, what to call this one? Transitive dependency, associative entity is being enforced, and uh, foreign key, primary key, foreign key is being modeled. Okay, so given this functional dependency, then you can proceed now to transforming this first normal form into second normal form. So to transform this to second normal form, you remove partial dependencies and full dependencies. How do you do this? Create one table for full dependency, one table for each partial dependencies. So this is how your second normal form looks like. You have there your report export form, which is the first partial dependency. When you look at this is the first partial dependency. You also have the report line, which is your full dependency from your diagram earlier, and your product, which is the second partial dependency. Notice that both the product and report line is already in third normal form. This is the reason for this is that you cannot break these two tables into or you cannot subdivide these two tables into another table because uh, all of the attribute containing these tables are describing what a report line is and what product table is all about. Meaning, example, si product, there you have here the product table. You cannot further subdivide this one because all the attributes present in the product table are pertaining to the product or describing product. Hence, you cannot subdivide it further. However, if you notice the report export, it is still in second normal form because it still contains the transitive dependency. So the goal of normalization is to eliminate full, partial, and transitive dependencies. So for us to eliminate this transitive dependency, then we can do the third normal form transformation. So to do that, you have to create separate table for export given this transitive dependency. So your third normal form will look like this. You have your report code, date, and export destination code. You have your export table. You have your report line and product. So notice that in the first table, your export destination code is underlined with broken line. This means that this is a foreign key, meaning a foreign key, it is a primary key from another table. In this case, export destination code is a primary key of export table. Okay, so all you have to take note is when you're going to assign foreign keys, you have to make sure that these foreign keys are primary keys from another table. Okay, so take note that you just have to keep in mind that normalization is similar to or similar to grouping together uh, entities that have similar attributes or similar characteristics. So I hope that this video will help you in your normalization activities. Thank you and good day.